Hello, everyone. Here is lesson 5.2, which is about function composition. So you're definitely going to want your Springboard book today. It starts on page 79. You will want a pen or a pencil and to take notes and probably your calculator. Let's get started. So to start off, function composition, lesson 5.2, we are going to write functions that describe the relationship between two quantities or two functions. And then we're going to explore the composition of two functions through a real world scenario. So here we go. We're still talking about Jim and his greens grass guaranteed. And it says here that on every mowing job, Jim charges a fixed $30 fee to cover equipment and travel expenses, plus a $20 per hour labor charge. So, number one says on a recent mowing job, Jim worked for 6 hours. What was the total charge for this job? So, we know that it's $20 per hour, and he worked 6 hours, plus his $30 fee to cover equipment and travel. So if we go ahead and multiply and add there, his total charge would be $150. Awesome. Then number 2 says, if Jim works for T hours, what will he charge? Write your answer as a cost function where C of T is Jim's charge for T hours. So now let's write it as C of T. And really all we're going to change is this 6, and we're going to say that it's T now, and that could be used for any amount of hours. So 20T plus 30 is your C of T function. Okay. All right, then it says here, it takes Jim 4 hours to mow 1 acre. Jim prepares a cost estimate for each customer based on the size of the property, so based on the number of acres that they have. Okay, so the Apcon company is one of Jim's customers. Apcon has 2 acres that need mowing. How many hours does that job take? Well, if it takes him 4 hours to mow 1 acre and they have 2 acres, 4 times 2 is going to be 8 hours. Okay. So then 4 says another customer has A acres of property. So again, this is what we would use if we didn't know how many acres. So write the equation of a function in terms of A for the number of hours T it will take Jim to mow the property. So we're going to write this as T of A because acres is what we plugged in there. And that's going to be written as 4A. Okay, so it says here, how much will Jim charge Apcon to mow its property? Justify your answer. So now we have to kind of think of this, and we first have to use number 3, which remember is 8 hours. And then we have to take that and plug into what we did for number 2, which was that C of T, where T was time. So now we would do C of 8, which would then give us 20 times 8 plus 30, which would equal $190. So that's how much Apcon is going to be charged to mow their 2 acres of land. Okay. All right. So let's keep moving here. And it says here, the functions in items 2 and 4 relate 3 quantities that vary based on the needs of Jim's customers. So the 3 quantities are 1, the size in acres of the property, 2, the time and hours needed to perform the work, and 3, the cost in dollars of doing the work. Okay, so basically the way we just did that, we kind of took 2 separate functions and use them and kind of put them together, but it basically took us like 3 steps. So the point of a composition is to compose those 2 functions so that it only takes 1 step. Okay, so number 6 says To complete the table below by writing the rate of change with units and finding the slope of the graph of the function. So remember, C of t was that 20t plus 30. And remember that rate of change and slope are the same thing, but the rate of change says with units. So slope, obviously, we can see is that 20, and the y-intercept would be the 30, right? So then rate of change, if we think about it in context, that is $20 per hour. And remember, your rate of change or your slope always has like a per or an each or an every, okay? All right, then our t of a function was equal to 4a. So obviously 4 would be our slope, with 0 being your y-intercept. And if we wanted to write that with the units, that would be 4 hours per a, which is acre. Okay, so that's how you fill in that table. Then 7 says, complete the table below by naming the measurement units for the domain and range of each function. Okay, so remember, domain is your x values, range is your y values, right? Okay, so what would we be plugging in this case? And whatever that x value is, that's going to be what's inside the parentheses. That's what you're plugging into your function. So in this first one, cost for job, it's going to be your time. And hopefully you can fit this in there, but time in hours. I'm just going to abbreviate there. And then your range is what you get out, which is the cost. Or the C, which is cost in dollars. Okay, so then same thing, T of A, the A or acres is what you plug in. And the T is time in hours, what you get out. Okay, so again, all you have to remember is basically that usually when we write a function, it's like written as f of x, and that x is going to be your domain, and then what you get out, the y, is going to be your range. Okay. All right. Then this next part says, excuse me, calculating the cost to mow a lawn is a two-step process. Complete the graphic organizer below by describing the input and output, including units for each part of the process. So if we were going to go back to this problem here, where it asked how much AppCon is going to be charged, the first thing we had to do is figure out how many acres of land they have. So that's your first input, is the acres. And we could say that's like the area in acres, okay? So we plug that in, and then the output is the time in hours, right? And that's using this function here. So the input was area in acres, and the output was time in hours. Okay, then that makes sense because whatever our output is, that's what we take and we plug into the next one. So we ended up getting, it would take 8 hours. So we took that and plugged it into the next one. So that's our next input also, time in hours. And then when we plugged in that time in hours, we got the final output, which was the cost in dollars. Okay. All righty. So that makes sense. And what should always happen here is these should match up in the middle. Okay, because whatever you get from the first input or the first output, you're going to plug into the next function. Okay. All right, cool. So it says here, the graphic organizer shows an operation on two functions called the composition. The function that results from using the output of the first function as the input for the second function is a composite function. In this context, the composite function is formed by the time to mow function and the cost per job function. Its domain is the input for the time function, and its range is the output from the cost function. Okay, so if you look over here, it has a little bit more about composition functions. But if we were to look here, we will find that, remember, area or your acres was the original input. And then basically what's happening is we're kind of eliminating that middle step. Okay, so that middle step that had the time, if we make a composite, sorry about that. If we make a composite function, we're eliminating that. So it's going to go straight from plugging in your acres to getting out the cost. And that's going to be nice for Jim because it eliminates a step for him. Now all he has to do is realize, okay, this is how many acres this company or person has. This is the cost it's going to be. Okay? So when a composite function is formed, the function is often named to show the functions used to create it. So the cost to mow function, C of T of A, is composed of the cost per job and the time to mow functions. Okay, so the C of T of A notation implies that A was assigned a value, T of A, by the time to mow function, and then resulting T of A value was assigned a value C of T of A by the cost to mow function. So basically what this means is that you always want to start on the inside, T of A, which was when we plugged in how many acres, and then you want to work your way out, so you would plug into C of T. Okay, so we're going to work on that, but let's call this new function the cost to mow. And again, now its domain, or what we plug in, is going to be acres. And what we get out, or the range, is going to be our cost, just like we saw up here. So now there's no longer any time. That part is kind of missing. Okay. All right, awesome. So it says here, Jim wants to write one cost function for mowing A acres of property. To write this, what he's going to do, so remember, we had our two functions, C of T, which was 20T plus 30, and we had T of A, which was 4A. Okay, now we want C of T of A, where you plug in acres here and you get out the cost here. Okay, so what you need to do in this case is you always want to start on the inside and work your way out. Or in other words, think of it working right to left, so opposite of what you're normally doing. So what you want to do is take your T of A, like I underlined here, and you want to plug that in for T in your other function. So basically this would look like 20, let me use a different color. 20, still in blue, and then in red, instead of T, we plug in 4A, and then plus 30. Okay, now we could simplify this here and say, okay, 20 times 4, so it's just going to be 80A plus 30. And that's going to be your function, okay, C of T of A. All right, so then 11 says to write a sentence to explain what this means. So C of T of 2 would mean that they have 2 acres to be mowed, okay, and you would get out the cost. Number 12 says, why might Jim want a single function to determine the cost? And that's just, again, because it's easier for him. And then 13 says, explain what the expression C of T of 50 represents. and that would mean they have 50 acres. So if they have that, you're going to plug in 50 to figure out the total cost. Okay, and 14 we're going to go ahead and skip. All right, so that's kind of a word problem way of doing this, but let's go ahead and take a look at how to just write these, okay? And you probably have some room at the bottom of page 83 to try these out. But in this first example, we have g of x and f of x, right? And what they want you to do is find g of f of x, okay? So what we are going to do is take this f of x and plug it into g of x. So again, I'm going to take this x minus 1, which is what f of x equals, and I'm going to plug it in right here, okay? So I'm going to write that as 3 and then times the x minus 1, and then bring down the rest of this, so plus 5, okay? So what we just did is we took f of x and we plugged it in for x in your g of x. And then you would distribute, and you would get 3x minus 3 plus 5. And then you would combine like terms here, and you would get 3x plus 2. And that's it. So that's what your g of f of x equals. Okay. Let's try another one. Okay. So this one is asking for g of f of t. All right. If you're feeling confident, pause the video and try this one out. Okay. Again, always start on the inside and work your way out. So we're taking our f of t and we're plugging that whole thing in for t in our g of t. Okay. So again, that's looking like 4. And then instead of t, we're going to plug in that whole f of t. So 3t plus 2. And then bring down the rest, so plus 4. That's the rest of your g of t function. Again, you're going to want to distribute. And you should get 4 times 3t is 12t. Plus 4 times 2 is 8. Plus 4. And then again, combine like terms, so you should get 12t plus 12. Okay, so that's where we're going to call it for today. Tomorrow we will do some more work with compositions during our Zoom. And then actually your video tomorrow will also be more work with compositions. Okay, all right, have a good one. Bye-bye.